In this video, I'm going to go over the EQ section in a bit more depth. So my previous video, I covered how I use the EQ section and generally the way that I use it when I'm mixing. In this case, in this video, I'm going to go over it again, but in more detail about the parts of it and what they're doing. So let's just jump right into it. So the first stage of the EQ, I'd say, is one of the most important. It's your high pass filter. This is not technically part of the EQ, and if you actually look at the block diagram for the SQ6, it's the first thing after trim, but there is EQs a bit later in the signal path, and you can actually pull stuff post high pass filter, but pre-EQ. But I'd say it's probably one of the most important parts of the EQ. It's doing the similar thing, pulling certain frequencies out. But in this case, what it's doing is it's allowing the high frequencies to pass from a certain point. So if I bring in my electric guitar here, so that's an amp with a microphone on it. It's going to be picking up a little bit of everything on the stage. Closer mic, the less of that you have to deal with it, and the higher the volume of the amp. But one of the first things we can do is to help clean up the signal is to add a high pass filter. So I'll bring that back in, and now I'm going to turn it on, and I'm going to roll the frequency up like I did before. So you can hear as I roll that up, we just lose more and more of that lower end. So that's the main purpose of this particular filter, is to pull out those lower end frequencies that we might not need for that particular input. So electric guitar is playing a bit higher up. That microphone is also going to be picking up subwoofers if the bass player is really digging in, or the kick drum. So the more of that low end that we can take out, the cleaner the sound is going to be. Now, this one's actually set to a 12 dB Butterworth. Butterworth is the name of the person who came up with the formula for it, but the main important number there is 12 dB. What that's telling you is that the angle of the slope is 12 dB per octave. So every octave you drop, the volume or signal is going to drop 12 dB. 12 dB is the lowest that this goes. If we jump this up, you can go to an 18 dB filter. So that's going to be a bit of a tighter slope. It's going to sort of kick out the bottom. And then we can go up to a 24 dB, and then it's even more of almost a straight up and down line. So that angle just changes as we jump through those. And it's just how quickly are we removing that low end. The lower the number, the less efficient it is. It's going to take, if I set it at 100 hertz, it's going to take a little bit longer to get rid of stuff that's just below 100 or around 100 compared to something that's a bit further back. But if we jump up to a 24 dB, then it's happening much quicker. The main benefit of going with the less is that it's less noticeable. It's going to be more musical. So generally use that unless you really need some more control on something and you need to cut it out. So we'll leave it on a 12 dB. Let's bring this guitar back in. Like I said, I generally go really high, and then I'll just roll it back till it's giving me the sound that I'm looking for without it sounding too hollow. So let's stick it there for now. So that's the high pass filter. That's all the settings you have on the SQ6. If you're on a different console, you might have a few other slopes available to you, or you might do the high pass using an EQ and switching it to a high pass. So if we jump over to our EQ section now, like I said, high pass, well, doing the job of EQ is technically a separate function on this specific console and some other ones. If we get into the EQ section, we can see that there's 4 bands available to us. We have LF, LM, HM, and HF. So that's low frequency, low mid, high frequency. Those are all available on the touchscreen here, but they're also on the side with some dedicated knobs. So these will work for every channel. You just have to make sure you select the correct channel. Now, on the low and high frequency bands, we have the option to switch the type of filter we're going to use. So if we go up to the high frequency one, we can see there's 3 symbols here, and the middle one is selected. So the middle one is our normal parametric EQ. It's got a nice slope there, and it's the frequency you pick is where the middle of that is, and it's going to go up to it and then come back down. How quickly that happens is determined by the Q value, which is, or width in the case of the SQ. So as I turn this up, I get up to 1/9, and that's as skinny as it'll go. And then if I go the other way, we can get up to 1.5, and you can see it's a very wide, long slope to it. Again, the benefit here is like how transparent is this? And as a general rule, if you're boosting, you're going to want to use a wider frequency range because it's going to slowly come up and come down, and it's going to fit in a bit more. If you're cutting, we generally try to be a bit more surgical. So if we boost up and hear something that we don't like, we can cut out that specific frequency. And the parametric is what all 4 of them default to, and then, like I said, you can only switch the outside ones. The other options here on the high end, we have a shelving EQ, and also on the low frequency. So now if I bring this one up, with a shelving EQ, it's going to slope up to the point that the frequency is set to, and then it's just going to sort of go straight back from there. This is most common in the built-in stereo systems in your car, where it'll say bass and treble. That's going to be one of these shelving EQs, and it's just going to be set at a specific frequency. In this case, your treble is probably going to be at 10K, and so when you boost that, you're sort of boosting everything from 10K up. And then with the bass one, then you're probably it's probably going to be around 100 hertz, and same thing. When you increase the bass on your car stereo, it's just going to boost everything from that point back. Finally, the last 2 filters that they add to the SQ is a high pass and a low pass. So this is separate from the actual high pass filter that you can adjust. This is mainly used in other circumstances where you don't have a high pass filter as an option. So you could use up one of your bands to just create a high pass filter and a low pass filter, which is the opposite. It lets the lows through, so everything behind that frequency point is let through. Everything past it on that slope is cut out. Okay, so to put that all together, if we bring this channel back in, I'm going to use that search and destroy like I did in the last one. See if I can find something specific that I can cut out. So I found a frequency that I'm not a huge fan of. I'm going to pull that out a little bit, and I'm going to do that as a very tight cut. But let's say I wanted to add some high end here. You can find sort of like that frequency, and then I'll use a wider filter to make it a bit more of a musical addition. So that's covers basically everything you can do with the EQ section. The high pass filter, you have different filter different types of filters you can use to adjust how quickly that's cutting out your low end. For the 3 boxes you have here, the top value is your width. The more to the right you go with the little meter, the skinnier it's going to be, and the more to the left you go, the wider it's going to be. The middle box is the frequency, and that's the center point for the filter. And in the case, that'll be where our little circle on the app is, or the square on our screen. And the bottom one is just how much you're boosting and cutting that frequency. So I hope that was helpful. Thanks for watching. If you like, you can check out the rest of my channel for more videos on similar subjects. And have a good day.